In this video, we will go over different advisory statistics available in AWR Report, such as Instance Recovery Stats, MTTR Advisory, Buffer Pool Advisory, PGA AWR Summary, PGA AWR Target Stats, PGA AWR Target Histogram, PGA Memory Advisory, Shared Pool Advisory, SGA Target Advisory, Streams Pool Advisory, Java Pool Advisory, Instance Recovery Stats. The Instance Recovery section in your AWR report provides information related to instance recovery, and specifically, the MTTR, Mean Time to Recover, Advisory. Instance and crash recovery are the automatic application of redo log records to Oracle data blocks after a crash or system failure. During normal operation, if an instance is shut down cleanly, as when using a shutdown immediate statement, rather than terminated abnormally, then the in-memory changes that have not been written to the data files on disk are written to disk as part of the checkpoint performed during shutdown. However, if a single instance database crashes or if all instances of an Oracle RAC configuration crash, then Oracle database performs crash recovery at the next startup. If one or more instances of an Oracle RAC configuration crash, then a surviving instance performs instance recovery automatically. Instance and crash recovery occur in two steps: cache recovery followed by transaction recovery. Cache recovery, rolling forward. During the cache recovery step, Oracle database applies all committed and uncommitted changes in the redo log files to the affected data blocks. The work required for cache recovery processing is proportional to the rate of change to the database, update transactions each second, and the time between checkpoints. Transaction recovery, rolling back. To make the database consistent, the changes that were not committed at the time of the crash must be undone, in other words, rolled back. During the transaction recovery step, Oracle database applies the rollback segments to undo the uncommitted changes. By analyzing this report, one can determine roughly how long the database would have required to perform crash recovery during the reporting period. The instance recovery statistics show how many blocks would need to be recovered if an instance crash were to occur. Essentially, any block that is not current at the time of the crash would need to be evaluated for roll forward then roll back operations. Use this section to tune the various fast start and recovery initialization parameters. Tart MTTR, this represents the target MTTR, the ideal time Oracle aims to achieve for instance recovery. Ested MTTR, this is the estimated MTTR based on the observed workload. Recovery Ested IOs, estimated number of IO operations required for instance recovery. Actual redo BLKS, target redo BLKS, log SC redo BLKS metrics related to the size of redo blocks in the online redo log. Log CKPT timeout redo BLKS, log CKPT interval redo BLKS metrics related to redo blocks flushed during log checkpoints. Opt log SC, optimal redo log size in megabytes. Ested RAC avail time, estimated RAC, real application clusters, availability time during recovery. Target MTTR, if the estimated MTTR, ested MTTR, is consistently higher than the target, consider tuning database parameters to improve recovery performance. Ideally ested MTTR, it should be close to the target MTTR. In this case, it is higher, indicating a potential for improvement. Lower values for recovery ested IOs are desirable. Redo log settings, review the actual, target, and log size redo blocks. Ensure that the redo log settings are appropriate for the transaction rate and sizing. Optimize checkpoint settings, log CKPT timeout, log CKPT interval, to strike a balance between recovery time and checkpoint overhead. If RAC availability time is a critical factor, consider adjusting RAC settings and configurations. Evaluate IO performance, redo log settings, and recovery-related parameters. Optimize IO performance by reviewing storage configuration, disk layout, and caching settings. Consider using faster storage devices if necessary. Consider optimizing IO performance to reduce recovery time. MTTR Advisory. The MTTR Advisory section of the AWR report helps to increase the instance availability in case of an instance crash or failure. It provides recommendations for tuning the fast_start_MTTR target parameter. For that fast_start_MTTR target is set to a non-zero value, this parameter influences the mean time to recover, MTTR, representing the estimated time it takes to recover the database in the event of an instance failure. The result can be found in $MTTR_target_advice and $instance_recovery. Enabling MTTR Advisory. Enabling MTTR Advisory involves setting two parameters. Statistics_level equals typical. Fast_start_MTTR target 0. Fast start recovery can greatly reduce the mean time to recover, MTTR, with minimal effects on online application performance. Oracle continuously estimates the recovery time and automatically adjusts the checkpointing rate to meet the target recovery time. This method reduces the time required for cache recovery and makes the recovery bounded and predictable by limiting the number of dirty buffers and the number of redo records generated between the most recent redo record and the last checkpoint. Checkpointing is an important Oracle activity which records the highest system change number so that all data blocks less than or equal to the SCN are known to be written out to the data files. Size for this column represents different values for the fast_start_MTTR target parameter, indicating the target MTTR in seconds. Dirty limit, the estimated number of dirty buffers in the buffer cache when instance recovery starts. Dirty buffers are modified buffers that need to be written to disk. Cache writes of the estimated number of cache writes during instance recovery. Cache write FCTR, factor the factor by which the estimated cache writes should be multiplied. This factor adjusts the cache write estimate based on the chosen size for fast_start_MTTR target. Total writes the estimated total number of writes, including cache writes and others, during instance recovery. Total write FCTR, factor the factor by which the estimated total writes should be multiplied. Similar to the cache write factor, this adjusts the total write estimate based on the chosen size for fast_start_MTTR target. Total IOs of the estimated total number of IO operations, reads and writes, during instance recovery. Total IO FCTR, factor the factor by which the estimated total IO operations should be multiplied. This factor adjusts the total IO estimate based on the chosen size for fast_start_MTTR target. The advisory provides estimates for various parameters at different values of fast_start_MTTR target. A lower fast_start_MTTR target may reduce recovery time but could potentially increase system overhead. A higher fast_start_MTTR target may reduce system overhead but could increase recovery time. If you are investigating issues with slow log file sync and slow commits times, then you may want to also check if MTTR Advisor is slow. It may affect redo performance. Buffer Pool Advisory. The Buffer Pool Advisory section of the AWR report provides information about the estimated physical reads, time, and percentage of database time for reads based on different buffer pool sizes. The report addresses the question of determining the optimal size for your database buffer cache. It offers insights into the potential benefits or drawbacks resulting from the addition or removal of memory from the buffer cache. These estimates are derived from the current buffer cache size and the volume of logical and physical I/O operations. This report is valuable for optimizing the size of your buffer cache. The Buffer Pool Advisory aims to illustrate, through numerical data, the potential outcomes of adjusting the number of buffers in your buffer pool, whether increasing or decreasing. Graphing the size factor or buffers is a recommended practice for comparing against the estimated savings in physical reads. Note, the Advisor section is an AWR report is not based on the report snapshots, but on the whole activity since instance startup at the time of the end snapshot. There are two conditions for the Buffer Cache Advisory section to appear in the AWR and StatsPack reports. 1. Buffer cache should not be specified with the parameter db_block_buffers. 2. Parameter db_cache_advice should be set to on which is default value. Parameter db_cache_size, if specified, defines the size of default buffer cache. If an addition SGA_target0 is specified, db_cache_size defines the minimal size of the default buffer cache, and Oracle may allocate bigger size. If SGA_target0 is specified and db_cache_size is not, then the size of default buffer cache will be allocated by Oracle automatically without low limit. Parameter db_block_size determines the size of the buffers in the default buffer cache. Apart from default buffer cache pool or subpool, which is always present, buffer cache may have other subpools. Buffer cache advisory section will then have separate subsection for each of those subpools distinguished from others by a letter in the very left column of the section as follows. D. Default buffer cache, always present. K. Keep buffer cache if db_keep_cache_size parameter is defined. R. Recycle buffer cache if db_recycle_cache_size parameter is defined. N. Caches for non-default block sizes if defined with parameters db_nk_cache_size. The advisory section is read row by row. Start from the row where third field size factor equals 1.0. If there is more than one such row, you can choose any one below, as figures in all of them for our purpose will be close. Rows with size factor equals 1.0 show approximate actual size of the buffer cache during the time interval of the AWR or StatsPack report. The size itself is shown in the second column. Size for estimate, CHEM, it has been allocated either automatically if SGA_target0 or manually. Last field of this row, estimated physical reads, shows estimation of physical reads. From this row with size factor equals 1.0 and est physical read factor equals 1.0, you will look at the neighboring rows up and down. Rows down show how increasing of buffer cache size would influence reduction of estimated physical reads. Note how size factor increases and estimated phys read factor decreases. Rows up show how reduction of buffer cache size would influence increasing of estimated physical reads. Note how size factor decreases and estimated phys read factor increases. Changing size factor shows ratio of the proposed size of the buffer cache, increased or decreased, to the approximate actual size currently in use found in the row with size factor equals 1.0. Changing estimated phys read factor shows ratio of the estimated number of physical reads for the proposed, increased or decreased, size of the buffer cache to the number of physical reads calculated for the current size of buffer cache found in the row with estimated phys read factor equals 1.0. Analysis of buffer pool advisory section. Size for M different buffer pool sizes considered for estimating physical reads in time. Size factor, a factor indicating the proportion of the total buffer pool size. Buffers, thousands, the estimated number of buffers in thousands for each buffer pool size. Est phys read factor, a factor influencing the estimated physical read operations. Estimated phys reads, thousands, the estimated number of physical read operations in thousands. Est phys read time, of the estimated time spent on physical read operations. Est %d time for RDS, the estimated percentage of database time spent on reads. Increasing the buffer cache may help significantly. If the server is already struggling with memory allocation, VM_out_bytes 0, then more physical memory may be needed to be allocated to the server. Also, SQL tuning may be needed to decrease the cache buffer chains. Regularly monitor and adjust buffer pool sizes based on workload characteristics. Aim for lower estimated physical reads in time to improve performance. Consider the trade-off between buffer pool size and memory consumption.